frequency. Check back, look back now. You don't have note? Why? You didn't write it up? Chris, frequency is what? 2. How you get up? What's the formula? Check back. You win your last week? What we do last week? We do this last week. So frequency is 1 over period, which is 1 on 4, right? And the SI unit is what? Hertz. Very good. Nice. What is the speed of this wave? Vishesh. I think get that wrong, you're going to stand up whole class. Right, speed of the wave right here. And wavelength. Ethan. What is the wavelength? Wavelength is what? No, tell me the formula first. V over? V on F. V is 10, F is 0.25. So much is that? 4. All right, nice. So that's how we stopped last day. And then there were 2 types of wave. What were the 2 types of wave? What were the 2 types of waves? Longitudinal and transverse, right? And longitudinal waves, they had what? They had compressions and refractions. And an example of them were what? Sound wave. So today we're focusing on sound wave. Head up sound wave. Huh? When is one month exam start? Or do you want to say 14? I mean, so you're not the third course. So you're not recording, yeah, I'm recording to that. Right. So some of the things that we need to know about sound waves is that in order for us to hear sound, there must be a medium, right? Before we go into the notes, there's this popular experiment. I don't know if you all did it already, right? Where they took an alarm. You know what alarm is? It does make noise, right? So they took an alarm, right? And they set the alarm off. And without the glass jar in there, you were able to hear it. And then they placed a glass jar over it and they pulled all the air out. And inside here turned into a vacuum. What do you all think might happen? You won't be able to hear it, right? So the reason for that is that there are no air particles in here. So although the alarm is going off, there's no way for it to transmit the sound energy being produced from in here to else. All right. So what that shows is that sound needs a medium to pass through. That's okay? Yeah. Do you ever look at these speeds of sound? Where would sound travel is faster? Air or let's say on a metal? Which part? Yeah. Sure? Yes. No, metal. Right? The closer the particles are, it's easier for it to transmit the sound energy. Okay? So the more dense the object, the faster the sound travels through. All right? Anybody knows the value for the speed of sound? Right. So the value for the speed of sound is around 330 meters per second. What we are going to look at experiments to help find this. right? And a very simple experiment. You would have done it already. Ever do it? Right? There is one with clapping, and we'll do that in a little while. All right? So we're gonna spend some time on sound waves and do a couple of questions on sound waves, right? Anybody know what's a high frequency sound wave name? What's the name of it? High frequency sound wave. Ultrasound. Right? And you can use ultrasounds to get images. Okay? All right. Let's take some small notes now. Head up sound waves. Sound is transmitted. Small note, right? One line and a small note, right? Sound is transmitted as a longitudinal wave and it is produced by a vibrating system. And is produced by a vibrating system. Sound, first up, sound cannot travel through. Sound cannot travel through a vacuum. Sound cannot travel through a vacuum. If I can spell it, look at here. Right? It's on a answer, is it? Comma, it needs a medium, comma, it needs a medium in which to be transmitted. It needs a medium in which to be transmitted. Full stop. Sound can give interference. Sound can give interference and diffraction effects. I'll explain those two later on. Sound can give interference and diffraction effects. And is therefore believed to be a form of energy, which travels as a progressive longitudinal wave, which travels as a progressive longitudinal wave.
That's all. Now it's
So this here is a loudspeaker. Right? And what will happen is that the loudspeaker will vibrate in and out, right? The loudspeaker will vibrate in and out, and what will happen? It will disturb the air particles in front of it, right? Some of the particles will be close together. That's what we call the compressions. And where it's far apart, that will be your ref factor. What's that? Yeah, there's a loudspeaker, right? That's the air particles. So you have parts where the air particles close together, right? That's the compressions. And then where the air particles are a little further apart, that's the rarefaction, right? Yeah, that's like with the slinky. Where they're close together, that's the compressions. Right? I just try to show you via particles. Oh yeah, so that's quick.
Wow.
Are you ready? Show yourself. Alright, too bad. Underneath this, the speaker has a cone. Last little note, and then we give it the first note, right? Refractions here. No, refractions and not fractions. The speaker has a cone. The speaker has a cone. The speaker, yes, under this note, under this diagram. The speaker has a cone which is made to vibrate in and out. Which is made to vibrate in and out by an electric current. By an electric current. First up, when the cone moves outwards, the air in front is compressed. When the cone moves outwards, the air in front is compressed. And when it moves inwards, nah. Yeah, that's now. And when it moves inwards, the air is rarefied. I spell it, I spell. All it means is it gets thinner. Rarefied, and it means gets thinner. Right, I call it over. Right? When the cone moves outwards, the air in front is compressed, and when it moves inwards, the air is rarefied, that is, gets thinner. First up, the number of compressions produced. The number of compressions produced. The number of compressions produced per second. The number of compressions produced per second is the frequency of the sound wave. It's the frequency of the sound wave. And the distance between successive compressions is the wavelength. And the distance between successive compressions is the wavelength. Last thing, wave parameters. Yeah. After distance is between successive compressions is the wavelength. The distance between successive compressions is the wavelength. Last thing, wave parameters of sound waves. Wave parameters of sound waves. Yeah, and next subheading. Wave parameters. Right now. Huh? Yeah. Wave parameters, right? Sound waves have two important parameters. Sound waves have two important parameters. Sound waves have two important parameters. Sound waves, yeah. Oh gosh, that's what we're doing. Number one, pitch. Number two, loudness. Number one, pitch. Number two, loudness. Right? Pitch and loudness. Pitch is dependent on what? Frequency. Pitch is dependent on frequency. So if something has a high pitch, that means it has a high frequency. If something has a low pitch, it has a low frequency. Loudness. Right? Sound waves have two parameters, the pitch and the loudness. Pitch dependent on frequency, loudness dependent on the amplitude. Right? A large amplitude, loud. Small amplitude, soft. So if you vary your frequency and your amplitude, you could alter the pitch and the loudness. Okay? There's one other thing I want to show us. I think I've talked about it already, where they watch the guitar from inside.
Oh,
See that?
yeah, talk to me.
Oh, the back is short. Oh, it's short, the picture there, that's fine.
No, you can speak from TikTok. Yeah,
I do my shadow.
no, you can take it one. The last thing I thought. Yeah, but I don't think what someone seeing nothing. Yeah. Yeah.
Alright, so here we have four waves. Right? Here we have four waves. Chavi. Let's look at wave A and B. They have the same amplitude, right? But we can't see it, but they have the same amplitude. Which of those waves you think has a higher pitch? B has a higher pitch. Why? And what does put them together mean? Higher frequency, right? More cycles per second. Right? Annalie. Which one here is louder? Why? Bigger amplitude. Right? So C is louder than D, B has a higher pitch than E. Alright? Try and join them with the same amplitude out there. Okay? And try and join these two with the same period. Alright, online. So what you're seeing, there are four different waves. First two, we can tell the difference in pitch. So we said this has a low pitch. This has a high pitch. Right? This one is louder. This one is softer. Finish? Finish. Last thing. Last thing underneath this. The quality of the wave. The quality of the wave. The quality of the wave depends on. The quality of the wave depends on. It depends on what produces the vibrations. What produces the vibrations? And how it is produced. And how it is produced. How it is produced. And how. So for example, right? You could produce sound waves on stringed instruments. And you could produce it on stringed instruments. Okay? And the quality is dependent on what producing it and how it's produced. Okay? So pitch, loudness, and quality is dependent on what producing it. You're done? Last thing. How to find the speed of sound. How to find the speed of sound. Wait, think of they try to the person is called find it.
I think that let's go and get who.
All right, so the last thing we have to do is to find the speed of sound, right? Right, so what you see here? What you see, a real simple example, right? So let's say we have a wall, right? That's a wall. And we have somebody here, right? You have somebody here producing a sound, right? Chris, are you watching? We have somebody here producing a sound. For example, you can have two pieces of wood and they're tapping them together, right? And what you will do is you are going to observe how long it takes, sorry, right? How long it takes for you to hear the echo, right? But what is the echo? Right, the echo is the sound that you are hearing after it travels from here back to here. That's okay? So the sound would have traveled twice the distance. So let's call this distance D. So echo travels 2D. Everybody okay with that? So the echo travels 2D. So if we have the time taken to travel 2D, how are we going to find speed? How are we going to get the speed of sound? How will it be? So we know that, right? Speed is equal to displacement over time. Actually, am I right? Speed. Speed is equal to distance over time. Right, so what I was saying? So after we find the time taken to hear the echo, what to do? That'll be a T and what going here? D of 2D. 2D. This is the time taken to travel 2D. 1, 2. How's even that? All right. So in order for us to get the speed of sound, all we need to do is to listen for the echo, we travel 2D and divide that value by however long it took. And you should have the speed of sound. Right? So just catch that there and we'll just give it 4 steps, right? Right, step 1, Setup as shown above. Step 1, setup as shown above.
Oh.
Oh yeah, right in here. Sorry, yeah. Step 1, setup as shown above. Step 2, find the time taken. Step 2, find the time taken. Find the time taken to hear the echo. Find the time taken to hear the echo of the sound produced. Step 3, find the speed of sound. Step 3, find the speed of sound. By using the formula, this speed is equal to distance on time. By using the formula, speed is equal to distance on time. Right? And be specific, equal to, instead of writing speed is distance on time, write 2dmt, right? Right? More favor. Try this question, please. Much? Oh, put number 4. And then leave it blank.
Yeah.
Oh yeah, try this, please. Try this same thing. Come on, value again. Online message a value, please. Try that, please. Come on, value again.
Check it out. I'll get that.
Step 3, look at here. Colleen, it on the whiteboard still. Distance on time. Speed is distance on time. Huh?
You can see on the screen. There's only one signal. After one,
Oh yeah, try that part more again. Well done.
You really make up yourself.
Oh yeah, we're going to take up those.
So this fella this in the classroom. I know I don't this.
Finish? Oh yeah, this should be done. You all done? Chris, all I get you? How much you got? What are you showing my way time? Chris, all hurry up now. Are you done? All finished? Hold the woman. Oh, yeah, I'm gonna say, I know the father. I know.
Oh,
What is it? Nothing? What about? One plus now? How much? Seven.
Will you use an example?
What you means? Right, Chris, what you got?
What?
What? Who's that here there? Right, Chris, do the whole thing here, come on. How far is he from the wall? 100 meters from the wall, right? So Carl claps 2 wooden blocks and there's a series of echoes, right? After 1 echo, he stops the watch. The process is repeated. So you have 50 echoes in 30.3. So how much is 1 echo? 1 echo is how much? Chris, how you get that? Yeah, listen. Divide what? 50 by what? Sure, it's not the other way around. 30.3 divided by 50. How much is that? 0.6? Exact? Alright, 0.606. So that's the time, right? Okay.
No, it's what they're looking for.
Now let us find out the course before leaving, you know.
No. I have something.
Yeah.
Severe?
Right, yeah, so Chris, let's finish it up. So the echo is 0.60 seconds, right? How do we find speed again? Distance over time. So what will be the distance you are using? 200, very good. And timers? Right, 0.606, right? That's okay? And when you divide it, what you'll get? No. What you'll get? 313. Oh, yes. That will be the exact answer.
Yeah, but if you don't want to be okay, for 6 1, yeah.
You okay with that? Are you okay with that? Next one, one more. One more. Copy down if you didn't get it.
It's a 9 minute drive. She's up back here right now. I think.
Yeah. Yeah. Are you ready? Try this next one here. Given that, last one I'll be done. Well, sort of. Given that the speed of sound is 330 meters per second in air, given that the speed of sound is 330 meters per second in air, and the speed of light is 3 by 10 to the 8. Part 1, explain why. Part 1, 3 by 10 to the power 8. Part 1, explain why an observer sees the flash of lightning then hears the thunder. That's part 1. Huh? Just come on, sit in front. I'll find you to be listening in the back there. Find you to be listening. Explain why an observer sees a flash of lightning before he hears the thunder. Answer that fast. Now give part 2. That's not free, write it down. I'll pick somebody else. Right, so part 1 is that. Write your answer. Let's pick on somebody online. Who to pick on you here?
I want us to know. Yeah.
Who? Justin. Who? Justin, you there? Justin, help out now. Why do we shut? Just now, Justin. Right, Justin. Why? Tell me why now.
Because light travels faster than sound.
Right, easy explanation. Light travels faster than sound. So already happen at the same time. Light travels faster than sound, so we'll see it before we hear it. Okay? And part 2. I sorry, I'm seeing something. I'm coming on the for you. Yeah. During a thunderstorm, part 2, last part. During a thunderstorm, A flash of lightning is seen. A flash of lightning is seen.
What about until you know. It's. Yeah, you.
Right, during a thunderstorm, a flash of lightning is seen, and 9 seconds later, the sound of thunder is heard. Full stop. Using the speed of sound given, using the speed of sound given, using the speed of sound given, estimate how far away the lightning is. Estimate how far away the lightning is. Wait, it's two. I thought it's one or the other. Oh. Try that fast. Online message answer. How far away thunderstorm? How far away is the light? You both have anything time, 9 seconds. 9 seconds, I'll give you. 9 seconds.
No, just show it. It's not nice. No. Do something. This also means that is.
Student send his answer already.
So what's the again? Yo, why right? It depends.
Right? Use the value I gave you. Actually, I'm right?
That's the hook.
Are you done?
Yes. My first was there. It's not the most I
Gotta change it here. Right, message values, messaging. What I get you? It is what? What's the formula for speed, Joshua? What's the formula for speed? Right, so you want to find what? Distance, so distances. Yeah, read the formula for me. Distance is what? Speed by time. Distance is speed by. Speed is how much? 330, and how long did it take? 9. So the answer is 2970 meters, right? So it's about 3 kilometers away. All right, we'll stop there. Right? Next, if we take a look at with parameters, reflection, refraction. Next week, right? Oh, I know. I don't like.